Hey guys, I'm Sid and today we are going to discuss Sieve of Eratosthenes problem on Geeks for Geeks. So let's see what the statement is saying. Given a positive integer n, calculate and return all prime numbers less than or equal to n using the Sieve of Eratosthenes algorithm. So till now what we were doing to find prime numbers is like we were taking an integer n and we take a loop here where we take integer I in the loop, and if n modulus I equals to 0 then it was not prime, and if n modulus I not equals to 0 then we return it as a prime. But here we have to use Sieve of Eratosthenes algorithm. We are not going to discuss much about this algorithm here, but to have a rough idea about this algorithm, what we are gonna do here is like we will take a vector and initialize all values of that vector to 0, and then we will take the multiples of our integers and will initialize those multiples to 1. Now at the end, the indices that are left initialized as 0 will be our prime numbers, right? So this is how Sieve of Eratosthenes algorithm works. So if you wanna know more about Sieve of Eratosthenes algorithm, you can of course learn about it. But here I am just going to write the code of Sieve of Eratosthenes. Okay. So I have given the rough idea. Now let's code. We'll take a vector here. Vector int means vector of integer type and naming it as prime, and till size n plus 1, sorry, n plus 1 will initialize all values to 0. Why we are taking n plus 1 here? Because the indices in the vector will start from 0 and we have to take the whole size of vector and initialize it to 0, so we are taking n plus 1. Okay, suppose we have taken n equals to 10 and it will start from index 0, so the whole size of that vector is going to be 11. That's why we are using n plus 1 here. Got it? Now we'll apply a for loop here. For int I equals to 2 and I into I should be less than or equal to n, and then increment the I operator I plus plus. You must be thinking that why we have used I square here. So this is for the optimization. Means if suppose we have our vector till let's say 10, okay, and we don't have to go through the last index. We just have to go till the index where the square of that number is going out of bound to that vector. Okay, that's why we are using I square here. Like the square of 3 is 9 and the square of 4 is going to be 16. So 16 is not in our size, so it will show error. So we just have to go through the size that is inside our vector. Okay, so we'll use I square here so that our loop will run till I square is less than equal to n. I hope you got it. Okay, now if prime I equals to 0, close this bracket. So we have applied a condition here which is if prime of index I equals to 0 means we have initialized our indices to 0, and if it is 0 then we'll use for loop again here for int j equals to I into I, j less than equal to n, and j plus equals to I. So this whole logic is for the multiples of that index. Okay, got it? So j is going to be I square, and it will run till j is less than equal to n, and then we'll jump to the multiple of that j. Okay, hope you got it. Then we'll write prime I equals to 1. Not I, we will use j here. J equals to 1. So if that index has multiples, we will initialize it to 1, and this will continue till I square is less than equal to n. Okay, now we'll create another vector here to return our answer, which is going to be integer type vector int answer. We will name it as ans. Okay, we'll use for loop, and we'll take int I equals to 0. Not 0, we'll take 2, because 0 and 1 will not be considered here. Okay, I less than equal to n here, and then I plus plus. Okay, we have applied for loop here, and if we are using a condition, if prime of I equals to 0, then we'll push back our index, our index I here in the vector ans which we have created now. Index I. Okay, then we'll return our vector ns. Okay, so we have written our code here. Let's run it, compile and run. So our case has been passed. Let's submit it. Yes, problem solved successfully. So yeah guys, this was the code. We can say this was the simple code for Sieve of Eratosthenes problem, and it is the optimized way of finding prime number. Okay, so hope you guys got it. We'll meet in the next video. Till then, bye. Thank you.